All right, so we are writing equations of lines now, not just finding the gradients of these tangent lines, but we are going to actually write the equations of these lines, and we're going to be doing some more rules of derivatives. So, we're going to be able to write equations of tangent and normal lines, so we'll talk about what a normal line is, and we're going to find the derivative of more complex functions, okay? So, to start out, the normal line at a point on a curve is basically the line that's perpendicular to the tangent line at that respective point. Okay? So what you see in the picture is just an example of what that would look like. The orange line represents the curve of a particular function. The blue line represents the tangent line. Okay, so when we take the derivative of the equation, we're actually finding a rule to find the slope of the tangent line. And the green line represents the normal line. Okay, the normal line is perpendicular at that respective point where the tangent line hits the curve. Okay, now perpendicular lines, let's see if you remember. Perpendicular lines have what? What do you remember about perpendicular lines back from your geometry days? Okay. What anything else besides the fact that 90 degrees? Maybe something relating to their slopes.
Oh, got it.
A little more, not just the reciprocal. It is the opposite reciprocal, okay? So when you find the derivative of a particular curve and you evaluate it at a certain point, you're finding the slope of the tangent line. But if the question asks you to find the slope of the normal line, all you got to do is take the slope of the tangent line, flip it, and then change the sign as well. Okay, you got to do the opposite reciprocal. Then you'll find the slope of your normal line, and then go on from there. Okay, so remember, you got perpendicular lines. Their slopes
Look at that.
are opposite reciprocal. Okay, their slopes are opposite reciprocal. Now, when you are writing the equation of these lines, again, this time we're thinking back not to geometry, but to algebra 2 or algebra 1. How do you write, what's the equation for a line? You have y equals mx plus b. This is known as what? Slope intercept form. Yes, slope intercept form, okay? There were two other ways to write a line. You had slope intercept form, you had standard form. What's standard form? You need a y in there. Ax plus by equals c. You had standard form, and then you had one more. Point slope form. Anybody remember the equation for point slope?
Y2 times
Think about it. Point slope form. Everybody remember point slope form?
But it's in the reference book.
Okay, before the parentheses is the slope.
It's the slope, yep.
That's x1 minus x. Oh gosh.
Just x minus x1.
Okay.
So whatever the point was, you did x minus the x coordinate, and over here was y minus y. These were your different ways to write the equation of a line, okay? Now realize that the IB exam is actually writing any one of these three ways. However, if it doesn't say which way to write it, the easiest way to write the equation of a normal line or the tangent line is point slope form. Why? Because when you take the derivative and plug in the x value, you have the slope, and more than likely you're also given a point, so why not use point slope form? Okay? That'd be the easiest way to write the equation of your tangent line or your normal line. So we're going to look at an example. We're going to write the equation of each line. Okay? So we have, well, actually we're going to have a lot of examples. So I'll give you guys a second to write these down. All right. So it says the tangent line to the curve of f of x equals x squared plus 1 at the point 1, 2. So it's pretty simple. First off, the tangent line means you gotta find the what? You gotta find the derivative. So we find the derivative of the function. This is a pretty simple one, but like, you know, we start off easy, work our way to the more challenging ones. What's the derivative of x squared plus 1? 2x. That right there, that is the rule to find the slope of any tangent line at any point. But we're looking for this specific point of 1, 2. So from here, we're going to do what? Plug in the x value to figure out what's the slope exactly at that point 1, 2. So when we plug it in, we get the value 2. That right there is the slope of the tangent line. So now we need to write our equation. Well, since we have our slope, aka our gradient, and we have our point, we use point slope form. So it's going to be y minus 2 equals 2, the slope, x minus 1. And that's it. Now, if you wanted to write in the slope-intercept form, you can always go from point slope to slope-intercept form easily just by distributing the 2 and then adding the 2 over. Simple as that. Okay? Let's look at the next one. It says the normal line to the curve f of x equals 2 square root of x when x equals 9. Couple of things you got to be aware of here. Normal means what? It's the opposite reciprocal of the tangent. So once you find the slope, you got to do the opposite reciprocal. And unlike a, we only know the x value here. How do we find the y value? Plug it into the original function. When x is 9, what's y on the original function? So let's do that real quick. It's what? It's going to be 6. So you have 2 times the square root of 9, 2 times 3. So your y value is 6. So you do have your point. You just had to find it first. So 9, 6. Now let's find the derivative. Might be easier for us if we actually do 2x to the 1/2. And let's take the derivative, bringing that 1/2 to the front. What's 1/2 times 2? 1. And now we're going to do what's the exponent? Subtract 1 to get. If we make that positive, that's going to be a x to the 1/2. And since we are actually trying to figure out what the slope is, it might actually be easier for us to write this back in its radical form. So that's going to be 1 over square root of x. Everyone okay so far? Now we need to find the slope. So we're going to plug in what value? Huh? 9. So I have 1 over the square root of 9. You see how much easier that is to have it in the radical form versus in the exponent form? What's the square root of 9? So we have 1/3. That 1/3 represents the gradient of the tangent. Okay? So then the slope of the normal line is going to be what? It's always the opposite reciprocal. The normal line is always the opposite reciprocal. So now that we have our slope, we have our point, we write our equation. Y minus 6 equals -3 x minus 9. Yes?
Okay, so the reason that it's -3 is because you go from, whenever you plug it into the equation, it's the equation of the curve, so you're finding the tangent by plugging it in.
When we find this rule here, this is the rule to find the slope at any point.
Okay.
Since we're looking at specifically at 9, 6, we plug in 9. This right here represents the slope of the tangent line. And tangents and normals are always perpendicular to each other. So it's like we have to figure that out in order to find the slope of that normal line.
So that becomes the tangent because you found it at one point.
Mm-hmm.
Okay.
Let's look at some more. we have to find the tangent and normal lines to the curve f of x equals x plus 27 over 2x squared when x equals 3. Now, just like B, we don't have a y value here, so we need to find it. Okay? When we plug in 3 for x into the original function, we'll figure out what the y value is. So it's going to be 3 plus 27 over 2 times 9. Anyone? Huh? 9 over 2. So when we add that, oh, the final answer is 9 over 2? Oh. Final answer is 9 over 2. So that's your y value. Now we need to figure out the what? We need to figure out the slope. To find the slope, we need to do what? You gotta find the derivative. Okay? Okay. So, the derivative of the function, derivative of x is what? 1. Okay? Now for this other part, you have 27 over 2x squared. You know, well, hopefully, did you write it like that? Okay? The square is only attached to the x, not the 2 as well, so you could just move the x up, leaving the 2 on the bottom, making it a 27 over 2. X to the negative 2. When you do the derivative of that, it'll turn into a negative 27x to the negative 3. You guys get that? Okay. So remember, you can bring your exponents up to the top by making them negative. That 2 only applied to the x. So you could have done it that way. Another way you could have done it. I'm not quite sure how you could have done it. Well, I do. Make that exponent positive, so that'll be a 1 minus 27 over x to the third. And there's our rule to find the slope at any point. How do we find it at 3 specifically? Plug it in. 1 minus 27 over 3 cubed, which is nothing but 27. So you have 27 over 27, which is 1. 1 minus 1 is 0. If the tangent line has a slope of 0, that means the tangent line is a what type of a line? It is horizontal. It is horizontal. So your tangent line is horizontal. Horizontal lines, what are their equations? Y equals. So, if the tangent line is horizontal, that means the normal line is vertical. Horizontal and vertical lines make perpendicular lines, okay? Vertical lines have the equation what? X equals. So to write your equation of your tangent line and your normal line, you basically just need the points. What's the x coordinate of the point? X coordinate is 3. The y coordinate is 9 over 2. So that happens again when you figure out that the slope of your tangent line is horizontal, then you know automatically your normal is going to be vertical. And you write them as their respective lines. Questions? D, the tangent to this curve that is parallel to the tangent at 4, negative 21. Parallel lines, what do you know about them? They have the same slope. So if they have the same slope, then you know all you gotta do is really just find the slope, right? Okay, so let's take the derivative. Do the derivative of this function. derivative. Alright, so that's your derivative. Now it says we're looking for the tangent line that, or we're looking for the equation of the tangent line that is parallel at this respective point. Okay? So that basically means that we have another line that's parallel, which means it's going to have the same slope that it has at that respective point. So, what do you think we can do from there to figure this out? What do you think? And how do we do that? By plugging in 4. Okay, so when we plug in 4, what do we get? What do you get? What's the slope? 11. Yes, the slope is 11. Okay? So that means the slope of the tangent line is 11, which means that the line that we're writing that's parallel to the tangent line is also going to have a slope of 11. Okay? Now the only issue that we have here is that we do not know the point. Okay? Because this point is for the tangent line. We're looking for the one that is parallel. So we need to find a whole nother point in itself. Okay? We do know one thing. We know the derivative, which gives us the slope at any point, and we know that the slopes have to be the same. Okay? So we have the derivative, and we know the slope has to be 11. We can figure out that other point by doing what do you think? Equaling it. Because no matter what, we know that this whole equation here, this 3x squared minus 6x minus 13, has to equal 11. Because their slopes have to be the same, right? That's what parallel lines mean, correct? So now we need to solve this. This is a good old quadratic. And how do you solve a quadratic? Set it equal to 0. So that's 3x squared minus 6x minus 24. And how do you solve a good old quadratic? Factoring or Euclidean square or quadratic formula. Okay? This one here, you should be able to recognize that every single term is divisible by 3. So you can factor out a 3, and then maybe it'll make it a little bit easier to see if you can factor to solve this. So we can factor out a 3. We'll have x squared minus 2x minus 8. When we continue to factor, we'll have x minus 4 and x plus 2. When we set both of these equal to 0, we'll have x equals 4 and x equals negative 2. Now that 4 here is the 4 that was originally given to us in that point. So we don't need to use that one. We're going to use the negative 2. Because the negative 2 is going to be the x coordinate for the point of the line that's parallel. Questions up to here? All right. How do you find the y? Plug it into the original equation. So to figure out our y value, we're going to plug it back into our original. When we plug in negative 2 into our original, we get 21. So our equation, using our x and our y, and the slope is going to be y minus 21 equals the slope, 11, plus 2. Because remember, it was, x minus x1. And there's our equation for our line. Try these two on your own. Try these two on your own. All right, so find the equation of the tangent and normal lines for the graph that we have here at point 3, negative 3. So you had to find the derivative, which was what?
3x squared. Wait, no, 2x
2x minus 4, and then you have to actually plug in the value of 3 to get. You got 2. This right here represents the slope of the tangent. So then what would be the slope of the normal? Negative 1/2. So then your two equations, since you already have your point, would be y plus 3. This would be for your tangent. And so then the other one would be y. And that would be the equation for your normal. For this one, it says find the equations for all vertical normal lines to the graph of x to the third minus 3x, okay? Now you already know that if it's a vertical normal line, what's the slope of a vertical line? Okay.
That's what's on.
Vertical lines have a slope of what? Come on, y'all. Algebra 1. What's the slope of that line? There is no slope. There is no slope.
It's a trick question.
Okay? There's no slope. But if there's no slope for a vertical line, then that means that its tangent line has to be what? Has to be 0. Okay? So if you're trying to figure out, okay, well, what are the equations for all the vertical normal lines to the graph of this particular thing, then you need to figure out the derivative. So the derivative equal to 0 because you know that's what the slope is for the tangent line, and then you'll figure out exactly what x equals, because x equals represents the equation for all vertical lines. What's the derivative of this? When you set that equal to 0 and solve it, you'll get 3x squared equals 3. X squared equals 1. When you take the square root, you'll have x equals and those are your equations for your vertical lines.
Oh, okay. Yeah, I think we're overthinking it again.
Okay? Alright, so this is the last example we're going to do. It says the gradient of the tangent line to the graph of this function at x equals 1 is 1. And you have to find the value of k. Okay, k is going to be basically serving as your constant for that inside term there. And you have to find that value. Now you know that when x is -1, your slope is 1. So what does that mean? You have to find the derivative. Okay, so yes, you have to find the derivative, and then do what? Exactly, you plug in -1 and then set it equal to 1. So let's find the derivative of this function. Derivative of 2x squared is 4x. What's the derivative of kx? K, and derivative of -3? 0. So now that we have the derivative, we're going to plug in -1 for x, and we're going to set it equal to 1 because it says the slope is 1 when x is -1. So simple enough, we'll have 1 equals -4 plus k. So k is going to be what? 5. There you go. Alright, you can always check by actually figuring out, okay, well, if I have 2x squared plus 5x minus 3, when you take the derivative, of course, it's going to be 4x plus 5. When you go to plug in -1, do you get a positive 1? Sure do. So then you did good.